So here we need to express each of the following relations as the set of ordered pairs. Okay, let's begin with our first problem. Problem number 1. So R is a relation going from one set to another, and it's defined by the relation x equals to 2y. So what we'll do here, we will suppose that let the set A be the set containing the elements 2, 3, 4, 5 and 6. And we have another set B. P consists of the elements 1, 2 and 3. Now clearly R is a relation from A to B. What does that mean? That simply means that R is going to be a subset of the Cartesian product of A and B. This is the meaning when we say that R is a relation from A to B. Now what here is R? Now R here is a set which is defined by the ordered pairs x, y such that what is x here? X is an element that belongs to the first set A and y is an element that belongs to the second set B, and both x and y are related by the equation x equals to 2y. So this is how we will be using this definition of the given relation to find out to express it in the set of express it as a set of ordered pairs. Okay, let us begin. So here, since x equals to 2y, what we'll do, we will pick up different values of x and y. So let's say if we choose, if we consider x to be equals to 2, then corresponding y value that's going to be equals to 1. Now is 1 an element of the set B? Yes, that's true. 1 belongs to the set B. So this implies that we have 2R1. That means we have 2 related to 1, meaning 2 and y are going to form an ordered pair 2, 1 such that x equals to 2y. Okay, so next if we choose x equals to 3, then in that case y becomes equals to 3 over 2. So let's do that. If we choose x to be equals to 3, then y is going to become 3 over 2, which does not belongs to the set B. That simply tells us that x is not going to be related to 3 over 2. We can say x not related to y in this case. Okay, so if we choose x to be equals to 4. So if we choose x to be equals to 4, then the corresponding y value will be 2. 2 belongs to the set B, which means now we have a relation 4R2. Next, if we choose x to be equal, so we're going to skip x equals to 5. We'll go straight away go to x equals to 6. So corresponding y value that's going to be equals to 3. 3 belongs to the set B. So here we have a relation 6R3. Fine. So here we have obtained 3 relations, 2R1, 4R2 and 6R3. So using that we can now define the relation R. So this implies that R is simply going to be the set of ordered pairs. So 2R1, that is going to correspond to the ordered pair 2, 1. 4R2 is going to correspond to the ordered pair 4, 2. And finally 6R3, that is going to correspond to the ordered pair 6, 3. Fine. So the first problem 1 is done. Let's go to the second problem. So here in the second problem, R is a relation on the set. Here we have the set contains 7 elements and it's defined by this relation, the ordered pair x, y belonging to R, if and only if x is relatively prime to y. Okay, let's try to find out R. So here it's given in the problem that x, y, this is an ordered pair. This ordered pair is going to belong to the relation R. This is an ordered pair that belongs to the relation R. If and only if, this symbol means if and only if x is relatively prime to y. So here x is relatively prime to y. This simply means that x and y, when we take their greatest common divisor, that has to be equals to 1. So that means if we choose x to be equals to 2, so 2 is going to be, in other words, relatively prime means it is a co-prime. So here we can say 2 is co-prime with what other elements of that set. Now we have to be careful here. It's given in the problem that R is a relation on the set A. So that means if we consider this set to be A, R is a relation on the set A simply means that R is a subset of the Cartesian product of the set A with itself. That is the meaning when we say that R is a relation on that set, which means that if we choose x from that set A, y is also going to be picked up from that same set A. So 2, which we have picked up from set A, we are going to pick up another element y from the set A itself, such that 2 and that number is a co-prime. So what is that number where with whom 2 is a co-prime? So 2 is co-prime to, so here we have a co-prime with the number 3. So it's not going to be co-prime with 4 because the greatest common divisor will be 2. Then it's a co-prime with the number 5, and then it's a co-prime with the number 7. Fine. So next, if we pick up x to be equals to 2, so x to be equals to 3, now x is going to be, that means the number 3 is going to be co-prime with what other numbers? It's going to be co-prime to 2, it's going to be co-prime to 4, 5, and 7. So 3 is co-prime with these 4 numbers. Next, we're going to pick up the number 4. So if we pick up 4, 4 is going to be co-prime with, so it's going to be co-prime with 3, it's going to be co-prime with 5, and it's going to be co-prime with 7. Fine. Next, if we pick up 5, 5 is going to be co-prime to, we have 2, we have 3, we have 4, we have 6, and we have 7. So 5 is co-prime to 2, 3, 4, 6, and 7, except for 5 and 1. Then we have 6. So 6 is co-prime with 5 and 7. And then we have the last number 7. So 7 is co-prime to, we have 2, 3, 4, 5, and 6. Right. So we have successfully obtained the relative primes of, so that means 2 is going to be a relative prime to 3. So that gives us the relation 2R3. 2 is co-prime to 5, so that gives a relation 2R5. Then we have 2R7. Similarly, here we have 3R2, 3R4, 3R5, and 3R7. Then 4 is co-prime to 3, 5, and 7. So we have 4R3, 4R5, and then we have 4R7. 5 is co-prime to 2, 3, 4, 6, and 7. So we have 5R2, 5R3, 5R4, 5R6, and then we have 5R7. Okay, next we have 6R5, comma 6R7, and then we have 7R2, 7R3, 7R4, 7R5, and 7R6. So we have successfully obtained all the relations between x and y. Now we will each of the relations to form the ordered pair. So R is going to be this set containing the ordered pairs. So 2R3, that will correspond to the ordered pair 2, 3. Next we have 2R5, that's going to become 2, 5, followed by 2R7, which becomes the ordered pair 2, 7. So now we can form out the ordered pair. So we have 3, 2, then 3, 4, 3, 5. We have 3, 7, 4, 3, 4, 5, 4, 7, then 5, 2, 5, 3, 5, 4, 5, 6, 5, 7. We have 6, 5, and 6, 7. And then we have 7, 2, 7, 3, 7, 4. Next we have 7, 5, and 7, 6. So here we have expressed R as a set of ordered pair. Let's go to the third problem. Problem number 3. So here we have R, which is a relation on the set containing these elements, and it is defined by 2x plus 3y equals to 12. Okay. Now, what we'll do here, we are going to assume that the set is denoted by A. So let A be the set containing the elements 0, 1, 2, all the way up to 10. Now it's given here that R is a relation on the set A. This simply means that R is going to be a subset of the Cartesian product of the set A with itself. That's what it means when we say R is a relation on the set A. Okay, now we have relation here. So we have 2x plus 3y equals to 12. So what we will do, we're going to define the relation R such that it is the set of the ordered pairs x comma y, such that, what is x here? X is an element that belongs to the set A. So actually it belongs to the first set A, and y is another element which belongs to the second set A, which is A itself. And then we have relationship between both of the two numbers x and y. We have 2x plus 3y equals to 12. So using this, we have to convert this relation into a set of ordered pairs. Okay, let us begin. So what we'll do here, we're going to choose different values of x and y. So if we choose x to be equals to 0, so when x equals to 0, then what is the corresponding y value? The y value equals to 4. Is 4 a member of the set A? Does 4 belongs to A? Yes, 4 definitely belongs to A. So this means that we have a relation 0R4. Fine. Next, if we choose x to be equals to 1, then the corresponding y value, let's verify what is the value of y. So when x equals to 1, then the corresponding y value, that's going to be equals to 12 minus 2. So that's 10. So y is going to give us 10 over 3, which does not belongs to the set A. So here we can see that 1 is going to be not related to 10 over 3. So this is not a relation that we are forming. So we are not going to use x equals to 1. So what other values of x and y are possible? Now for the rest of the values of x, we have also obtained the corresponding y values. Here we can see here, when x equals to 3, we get y equals to 2, and clearly 2 is an element of the set A. Then if we choose x to be equals to 6, the corresponding y value equals to 0. Now 0 is an element of the set A. For all other values of x, the corresponding y value does not belong to the set A. So here we have only 3 possibilities in total. One is 0R4, the next will be 3R2, and then we have 6R0. So now we can define the relation R as a set of ordered pairs. So we have 0, 4. So 0R4 corresponds to the ordered pair 0, 4. 3R2 corresponds to 3, 2, and then we have 6, 0. So there are 3 ordered pairs which satisfies the condition that 2x plus 3y equals to 12, and R is a relation on this set A. Okay, let's go to the fourth one. Number 4, we have R, which is a relation going from the set A to the set B, and is defined as the ordered pair x, y belonging to the relation R if and only if x divides y. Fine. So R is a relation from the set A to B, simply means that R is a subset of the Cartesian product of A and B. Okay, so let's note down the set. So we have set A given by the elements 5, 6, 7 and 8. Then we have the set B. Set B contains the elements 10, 12, 15, 16 and 18. Now here x is going to belong to the set A and y is going to belong to the set B. Okay, now let's pick up x equals to 5. We have to pick up a very specific value of y from the set B such that 5 divides that number. So if we choose x equals to 5, then y must be equals to 10, because 5 divides 10. So we have a relation here 5 are 10. Next, if we choose x to be equals to 5, then y must be equals to 15, because we have 5 divides 15. Okay, now we will choose x to be equals to 6. So if we choose x to be equals to 6, then y must be equals to 12, because 6 divides y. 6 divides 12, then x equals to 6, and then we have y equals to 18. That means we have 6 dividing 18. Next we will pick up, if we pick up 7, there is no number in the set B such that 7 divides that number. So we'll straight away go to 8. So if x equals to 8, then y must be equals to 16, because 8 divides 16. So we have now successfully obtained all the relations between the set x and y. Now we are ready to form the relation R, which is the set of ordered pair. So 5R10 is going to correspond to the ordered pair 5, 10. 5R15, that's going to give us 5, 15. Next we have 6R12, so that's 6, 12. 6R18, that will be 6, 18. And then we have 8R16, which is 8, 16. So this is going to be the relation R expressed in terms of the set of ordered pairs, such that dx which belongs to the first element of the ordered pair is going to divide the second element of the corresponding ordered pair. 5 divides 10, 5 divides 15, so you get the idea.